Good afternoon and welcome. I'm Rebecca Vieira and I'm the coordinator of the Inter-American Teacher Education Network, or ITEN for short, an initiative of the Organization of American States. I'm pleased to welcome you all to this webinar in our series of webinars, Teaching STEM in Quarantine. Before continuing, I'd like to briefly introduce ITEN to those of you who are not yet familiar with us. The purpose of ITEN is to improve the quality and equity of education through teacher education in the Americas. To do so, we offer funds and activities for educational leaders with the intent to resolve problems of policy and practice related to STEM teacher education, in which STEM refers to science, technology, engineering, and mathematics. To learn more about us and how to get involved, please visit our website, which we'll share at the end of the presentation. Given by ITEN's project team participants, teacher fellows, and other network supporters, this series of webinars' objective is to support the efforts of teachers during this time of quarantine. In future webinars, again, to join future webinars, please continue to visit our webpage again, which we will share a little later on. This afternoon, we're pleased to have a presentation from Erik Salna from Florida International University. He's currently on a project team with participants from across the United States and also Jamaica, including the Jamaica Ministry of Education, Iowa State University, and Fairfax County Public Schools. The presentation and questions and answers collectively will not last more than 1 hour. And during the presentation, we welcome you to ask questions using the Q&A tool. At the end of the presentation, Erik will answer a select number of questions, however much time we have available to do so. The webinar will be recorded, and the recording as well as the slides will be linked to the ITEN COVID-19 webinars webpage. In about 24 hours, you'll also receive a notice that the recording is uploaded. You can use that message to serve as evidence of your attendance in place of a certificate in case you do need to show anything to administrators. Additionally, we'd like to express our gratitude to the Educational Portal of the Americas, which is providing support to transmit this presentation live via their Facebook page, and especially to our donor, the U.S. Mission to the OAS. At the conclusion of the webinar, there will be a survey that will show up, so please take a moment to fill it out and help us determine future webinars. So thank you again so much, and I'm going to go ahead and pass the presentation over to Erik.
All right, thank you, Rebecca. Can you see me and hear me?
Everything looks good, Erik.
Awesome, thank you. Thank you very much. Well, good afternoon, everyone. Really appreciate the opportunity to talk with you today and to have the opportunity now to be a part of this program and offer an online webinar about what I do and the science of meteorology. So for everyone that's out there, thank you for tuning in today. And if any questions come in to mind, feel free to start putting them in the chat as we've suggested. And then a couple of times during the presentation, I'll stop to see if there's any questions you may have at that point. And then we'll certainly go with questions and answers at the end of the presentation as well. So excited to be here, and we'll go ahead and just get started. So I thought the first thing we're going to do is give you a tropical weather briefing, since a big part of what I do as a meteorologist and working at Florida International University is to, we monitor the tropics. And there's a system out there, so we're going to get into that, what's happened currently, and then we'll get into the science of forecasting hurricanes as well. So with that in mind, I'm going to share the screen here, and let's see how this all work out, like this, like this. So there we go. Rebecca, do you see the satellite loop?
Yep, it looks great.
Okay, great, thank you. Well, when it comes to the world of weather, there are many, many different websites that you can go to, of course, right? To see satellite loops and government agencies, nonprofits, and so on. This particular website is called Tropical Tidbits. And I'm just went to this one to kind of show you the big picture of what's happening in our part of the world with the hurricane season. So obviously, here's the United States, here's Florida, I'm in Miami, and of course the Caribbean. And as we look at this, you can see that we have the spinning circulation here in the Atlantic, and that's our hurricane Epsilon. And here we are in late October, and we have Epsilon, which at one point had been a major hurricane. It's now decreased in strength, but that's our one hurricane that we have out there. And then I do want to point out here in the Caribbean, and for anyone watching from the Caribbean zone, this messy look, if you will, of lots of clouds and so on, that's what we call an area of disturbed weather or a tropical wave. And computer models are suggesting that possibly that there may be an area low pressure that will develop there, and then that whole area kind of moving to the north. So we'll be watching that closely for all our friends in the Caribbean and certainly Cuba into the Bahamas, Florida and beyond, just to see what that system does, if it affects anyone, and then where it goes from there. So from there, showing you the National Hurricane Center website. So as far as finding, what's happening in the tropics at this time, the National Hurricane Center, of course, is a go-to site to show you what is out there. And on that home page, they have this big map, kind of show you current systems. There's Epsilon. And then notice this little X. And so they will put X's on there, different colors too, to let you know what the probability of development is. And when you go to the bottom of that graphic, you'll see 2-day graphical tropical weather outlook, and then you go 5-day. And when you go 5-day, you'll see not only Epsilon, but notice the shaded area. They now kind of project, if you will, if there is going to be development, where it might be and in what direction it might be headed, just by the shaded area. So that's why we'll be watching that closely. Now, if we go back to the home page, and again, learning about Epsilon, and this is all their graphics for that. And of course, many of us are used to the cone for Hurricane Epsilon. And as we scroll down, here's the latest cone projections. It's going to be moving north and then quickly off to the northeast, through parts of the North Atlantic and beyond. And as of 2 o'clock anyway, it had maximum sustained winds of 90 miles per hour. So a category 1 storm. All right, excellent. So there's your current tropical weather briefing. Now let's get into the science of kind of how all this works and is all put together. So with that in mind, I'm going to, at this point, I think I'm going to stop share, and then I'm going to start it up again. And let's go ahead to that and share that and that and that. And okay, whoops, there we go. We'll go ahead to our display settings and duplicate. And there we go. All right, how are we looking, Rebecca? We see my first slide?
Yep, everything's fine.
All right, thank you. All right, so again, I'm Associate Director of Education Outreach at the Extreme Events Institute and the International Hurricane Research Center at Florida International University in Miami. And the picture behind me, by the way, that's called the Wall of Wind, which we're going to be talking about here shortly. But first of all, here's my contact information. Rebecca, how are we looking? Looks good?
Yep, everything's working.
All right. So there's my email address, my phone number. And if you do want to follow us on social media, there's our Facebook at FIU Extreme Events Institute, and Twitter at FIU Extreme Event, where we will then post different things that we're doing at FIU and with hurricane research. All right, so, well, what I thought I would start out with, first of all, is a little bit about myself. And this goes way back. This is a family photo. I have that little arrow there showing you that's me. This goes back to the 1960s. Grew up in the Chicago area, so I was used to the 4 seasons of weather. Here down in Miami, we just have 2 seasons, right? The wet season and the dry season. But I put that up because I wanted to show you this. There was a time when I was, at about that time when that picture was taken, a big lightning bolt hit a tree just outside my window, and it scared me to death. So I was very fearful. But what's interesting is how that fear then kind of moved in the direction of curiosity as to, now, how did that lightning bolt even get formed? How does weather get created? And that curiosity then grew to a passion. And that passion within your heart, right? I was like, I want to then be a meteorologist. And so I knew that would take a lot of hard work and then to make that dream come true. So when I talk to a lot of schools, I like to give that positive message of regardless of what they're going to study, follow your heart, follow your passion, and with hard work and with help along the way, mentors and tutors, you can make that dream come true, and then you'll be most happy. So I wanted to share that positive message, first of all, today for all of you. Hopefully that all of you are in your passion zone. And I give all of you credit. For many of you that are teachers, on the front lines, if you will, teaching the next generation of professionals and so on, you know, I give you so much credit with your teaching and what you're doing with the students. And that also, I'm sure that you're inspiring them too and encouraging them to work hard and make their dream come true as well. So for me, it was all about meteorology, the study of weather. So I carried that interest, of course, through into high school and then college. And so it falls in with STEM career, science, technology, engineering, and math. And I'll tell you, the math for me was not easy. It was actually very difficult, especially when I got to college. And I didn't do so well. I had to repeat some classes, and I had a decision that was to make. And that was, do I quit because it's too hard? The math is just too hard? Or, wait a minute, my passion, I can't avoid it. I'm not going to quit. I'm going to get my mentors, get help from teachers, tutors, and make that dream come true. So when I talk to students about STEM careers, I tell them sometimes it can get very difficult, but that's okay. It did for me too. Keep at it if that's where your passion zone is, to make it happen. And I took those math classes again, and the rest is history, became a meteorologist. Now, as far as the science of meteorology, because I will bring up how we're going to teach it in the classroom, you know, it's important to teach the science of weather, the science of a lightning or a tornado or a hurricane, how it works and how it gets created. But I also like to emphasize, don't forget to teach the safety as well. That's so important for all of us. It's good to know the science, but we need to know how to make ourselves safe. And just wanted to make that mention. So first part of my career, very blessed, I was in television meteorologist, where I was able to take my passion about weather and communicate it to viewers. And I still do that today occasionally, but for the most part, full-time, I'm now working at FIU and just every now and then pop up on television only as needed. So at FIU, we are the Extreme Events Institute and the International Hurricane Research Center, do many areas of research related to disaster risk and resilience in the Americas, the Caribbean. We have a Florida public hurricane loss model where it predicts what the loss of a hurricane might be in terms of damage in dollars, and a storm surge model where we work with the National Hurricane Center to predict how much surge may come up into a region from a hurricane. And the logo here, lower right-hand corner, Weather Retardation Ambassador, WRN. Any of you can become an ambassador too if you're doing educational type activities related to making your community resilient and safe to natural hazards. So just want to plug that. It's a NOAA program. All right, on our campus, we have this building. If any of you have ever been on our campus or not, this building is where the National Hurricane Center is located in conjunction with the National Weather Service. So all these forecasts and the National Hurricane Center website that we went to, all it is being generated from this building right on our campus. So it makes because of the close proximity, we're able to collaborate and partner in many different programs, research, and even education and outreach. I do want to also mention, working with the National Hurricane Center, we did create the Spanish language hurricane website, huracanes.fiu.edu. And this is created to be an additional resource to complement the information that the National Hurricane Center is putting out, all in Spanish, and want to make sure that you were all aware that's there as a resource. All right, I want to go back to the National Hurricane Center building again, because now the question is, do you see, can you tell what this building is made out of? What building material was used? It's obvious, concrete. right? They built the National Hurricane Center to be resilient. So if a hurricane should come over Miami and FIU, they won't blow away. They are a 24/7 government agency that needs to be there. So they built, so they will be resilient. And that's an overriding theme of today's presentation. Okay. All right, another question I have here, kind of a general question that will tie in with everything too, is, are there natural disasters occurring around the world? And when you think about that, you know, quickly a logical answer would be, well, yes, there's things happening everywhere. Well, the answer is no. Now, what do I mean by that? Well, this is what I mean by that, is that there are no natural disasters, okay? So look at point number one. Natural hazards occur all the time, but they only become disasters when they collide with human, physical, and economic systems. And point number two says, we've built our towns and cities where natural hazards occur. So the term natural disaster puts too much blame on nature and not enough on how and where we have built our communities and how we've created our own, what we call exposures and vulnerabilities. So maybe a bit of a trick question. That natural disaster term is used all the time, but just wanted to make a point. Natural hazards, running into where we have our cities, that's what causes then that disaster. So if you go to our website, front and center, we have this, what's called the hazard risk equation. And on the left-hand side, you have EMR, DR, and CAT-R. The right-hand side, H plus EX times V. So this is another way to talk about the natural hazard challenges. So on the left-hand side, it all has to do with the end result. So EM, was it an emergency? D, was it a disaster? Or CAT, was it a catastrophe? That's all dependent on the right-hand side. H is hazard, so let's say hurricane, plus EX, which is exposure, okay? How much building and people in harm's way, times the vulnerability. How well is that community prepared for that hazard? And those things, exposure and vulnerability, will really determine the outcome, whether it's an emergency, disaster, or catastrophe. So we're going to take the equation and just the bottom part, H plus EX times V. So using the equation, we'll say H, and in this case, we're going to go with Hurricane Irma, which affected Florida several years ago. So let's say that's the H. Now, let's go ahead and bring in now exposures. State of Florida here in the United States has exploded in population. And we have all the people, most of them color-coded in red, living along the coastlines, right in harm's way. In addition to that, an explosion of businesses and homes and hospitals, infrastructure. So that has increased. So again, people in buildings, so much more now than there were many years ago. And now, when we get hit by a hurricane, it can be devastating, but I want to bring up V, the building code. So how is Florida able to withstand a natural hazard like a hurricane? Well, this is a good picture. After Irma, it showed a house in the middle that was built to a building code in 2014. Houses on either end were built to the building codes in the 1980s. But after Hurricane Andrew in 1992, Florida woke up and said, we have to build better, build stronger, increase our building codes. And we're seeing the end result. We're seeing that now there can be less damage. And that's the whole goal. We have to stop this spin cycle of hurricane damage, rebuild, hurricane damage, rebuild. It's too expensive. We can't be doing that anymore around the world in all countries. And that's the point we're trying to make. All right. So for you and your students, we learned about meteorology and the science of meteorology. And now a little bit about the hazard risk equation and another way to talk about it, especially probably with your older students, but all students could learn a little bit about that, exposures and vulnerabilities, but wind mitigation. So how can we protect our home from hurricane wind. And there are ways to do it. And it makes good sense because every dollar we spend on mitigation saves at least $6 in damage and cleanup. So you present that to the students, they'll be, well, why aren't we doing it? That makes sense. Well, it's a lot of challenges as to how far we've come, and there's still work to be done so that we are doing it. All right, so how about this hurricane season? Well, looking at this hurricane season, boy, oh boy, oh boy, it's been historical. And in fact, we've had so many storms, we literally ran out of names, as you may have noticed. We went through the entire alphabet, which, by the way, it's usually the students kind of have fun with the name game. There's 6 lists here for our part of the world, and these 6 lists get rotated. So this year's list was used 6 years ago. And if there's a famous storm, a historical storm, they retire it to the Hurricane Hall of Fame and they never use it again. As far as this season, we went all the way from Arthur through Wilfred. And then what? What happens then? Well, we've had to go to the Greek alphabet. This has been the backup plan for the National Hurricane Center. We've only done this one time in 2005. I personally was hoping we would never see the Greek alphabet again because I knew if we did, it would be an historical season. And unfortunately, here we are in this season, 2020, and we had to go to the Greek alphabet. And now today we have Epsilon. Zeta is as far as we got in 2005. If we go past Zeta, then it'll be a season where we've never seen so many names, so many storms before. I'm hoping we don't break that record, but we're already on Epsilon. Okay, so back to a hurricane. And as we look at Irma, which was a powerful storm in 2017. So when talking about, first of all, the science of a hurricane and with your students, you know, what's the recipe for a hurricane? I always like to say, when you bake a cake, what's the recipe? What are the ingredients that you're going to need? Well, there's many different ways to illustrate that. But with a hurricane, basically, you're going to need lots of warm ocean water. You're going to need lots of moisture in the atmosphere, no dry air, and no Saharan dust. And you're going to have calm upper level winds, no wind shear, and an area of low pressure. So if you bring those ingredients together in the right way, that's what helps now, eventually the end result being a hurricane. And of course, we know there's 5 categories, 1 through 5, 5 being the strongest. And of course, you know, these categories can change with each and every storm. So what are the weapons of a hurricane? What does a hurricane bring to a community? Well, there's different ways a hurricane can affect the area. You can have storm surge. You can have tornadoes, inland flooding, obviously strong wind, and that strong wind can lead to rip currents at the beaches. And then if there's a storm out there, it's good to know and understand the forecast cone. What is it and how is it created? And when we talk about that, how is the forecast cone created? And what does the cone show us? And what does the cone not show us? Well, the cone, first of all, how is it created? Well, there's lots of computer models that try and predict track. There's many of them. And on this graphic, there's, with each and every storm, all these computer models will predict a different track. And we wish there was one model that was the best model, the most perfect and most accurate, that predicted the track of a hurricane, and we would just use that one model. And then you would just see a line, a skinny black line. Well, unfortunately, the science is not there yet. There's no one most perfect model. So all the Hurricane Center can do is encircle those models and create that cone. And remember, the cone, what it doesn't show us, this cone shows us geography. Where will the storm be in a certain point in time? 1 day, 2 days, 3 days into the future. But that's all it tells us. It doesn't tell us anything more than that. It doesn't tell us about the hazards. So when we look at a cone, it tells us, okay, where it might be, but in terms of storm surge and wind and flooding rains, that's not what the cone is trying to tell us. So this is an important lesson to know, that we have to understand that there are all these hazards. So go to the National Hurricane Center and your local National Weather Service office, and they will show you specific graphics showing you details of those hazards and how they may affect your particular community. Beyond the cone, you could start with the cone, but then you have to go to the hazards for that complete understanding. Storm surge. Water kills more people than wind from any hurricane. So storm surge and flooding. So knowing how storm surge occurs and your students understanding not only the science of it, it's the hurricane and the wind and the momentum of the storm pushing that water across the beaches, and the fact that they then can move inland and the danger that it presents. And understanding storm surge watch and storm surge warning, and what's the difference. And this is new in the last several years. We've always had hurricane watch and warning, but storm surge watch and warning is relatively new, and having an understanding what those mean, and of course why that's important. So where else do you go for information? Well, for here in Florida and other parts of the US, we go to our local National Weather Service office, where they will have specific graphics showing you specifically for Florida and Miami what that storm might do. Okay, now as far as getting the data from the storm, we're going to talk about who flies into the storm, and they are the NOAA hurricane hunters. So before we get into that, Rebecca, just briefly, have any questions popped up?
I don't see any at this point, no.
Okay, very good, thank you. So the hurricane hunters is a fascinating story. We have satellite technology and radar and computers, but we need aircraft, actual men and women to fly into the storm to get information about that hurricane, so we can put that data into those computer models. And when you talk to people and hear the stories of the people that fly into a hurricane, the way I present it to the students in class is, I ask them, have you ever been on a roller coaster? And what's that roller coaster ride like? Where you go up and you go down and up and down. And I say, well, think of that roller coaster times 10. Sometimes these aircraft are doing the same things up and down into the storm. They're very dangerous flights, but we need the data. So this one here from NOAA, the first one is a jet that flies at high altitude to get information. And then the propeller plane, the P3, literally flies right into the eye of the storm. And when they get there, or through the storm, they do the zigzag pattern, if you will, but they're dropping an instrument package called a dropson. And they're dropping that so it floats on a parachute and now measures humidity and temperature and wind speed. And that data is what's critical in forecasting the storm. And they're using drones, and this is in recent years, for research and to gather data, where they can fly that drone at the lowest level of the storm, the most dangerous area where you can't put aircraft. So it's an area that is expanding, and we're hoping to see better results from drones moving forward and how it'll help in the process. And then it's amazing what those hurricane hunters see when they get to the center of the storm, the eye. And you could see, we call it, the stadium effect. If you're in the middle of a football stadium or soccer stadium and you look all around you, that's what they see sometimes, where it's relatively calm and peaceful. But to get there, they had to bust through that eye wall, and they're all strapped down in seat belts and strapped down, because when they're flying into that storm, they're literally being tossed around and moved up and down, and then boom, they hit the eye, and then it calms down. But they only have a few minutes, because look what's ahead of them, the other side of the eye and the eye wall, where they have to do it all over again. So from this kind of information in the classroom, ideas for instructional activities: prepare hurricane forecasts. If you've learned what the ingredients are to make a hurricane, you can make a simplistic map and put dry air and moist air, and wind shear and no wind shear, and cold ocean temperature and warm ocean temperature. and these kinds of things. And then, okay, where do you think where that storm will form? And that's what the National Hurricane Center has to do too. Or take this information, knowing where the storm is, knowing where it's headed with the cone, and present a 2-minute weathercast. Record it, but use the concepts to now speak about the storm in a short amount of time to viewers that are out there that need this information. Another idea. Another activity is the Hurricane Jeopardy game. We all know the game show Jeopardy, but you can apply that game to weather content and hurricanes. Kind of a fun way to present the data and the information. Or we talked about the hazard risk equation. How about your community? How can we make it be more resilient? Well, you can maybe have the students as a class project create a resilience plan for your community. What are the ideas they would come up with? All right, so from meteorology and mitigation, from that now we're going to go to wind engineering, another STEM career. And this is where the Wall of Wind comes in. It's 12 giant fans that creates hurricane conditions up to Category 5 where we test structures. And I have a video here I want to share with you that'll tell you all about the Wall of Wind.
The 12-fan Wall of Wind facility at FIU, which we call the WOW, is the largest and most powerful hurricane simulation facility in a university setting that can simulate Category 5 hurricane wind, the highest rating on the Saffir-Simpson hurricane scale.
The Wall of Wind allows for wind loading experiments on various structures at multiple scales. And because it is an open-jet facility, it is capable of doing destructive testing on structures to study their failure and collapse modes without the risk of damaging the wind tunnel. The Wall of Wind can do holistic system-level testing. That means we can test structures with the components and connections as integral part of those structures and study the system-level performance. We can also look at wind-driven rain intrusion into actual building envelope, and we can study progressive damage of the system. So this is a new way of looking at hurricane impacts on building systems because building envelopes are one of the most vulnerable elements in hurricanes.
Here in the control room for the Wall of Wind, we can monitor a lot of the systems that are part of the Wall of Wind, but we can also control them. We can control our pressure scanning systems, wind speed measurement devices, load cells, force balances, transducers, and a lot of many other instruments that we have available in this facility. We also have a system with high definition cameras that we can see over here and record when a part of the model failed and how it fails.
Our safety program includes personnel safety, which includes trainings through the Environmental Health and Safety Department within Florida International University. Also includes safety protocol to ensure the safety of all equipment within the Wall of Wind.
The Wall of Wind is a very versatile wind testing facility. It can test up to speeds that are equivalent to Category 5 hurricane speeds, 160 miles an hour. And it also simulates the wind profile and turbulence of natural winds very well. So we have already tested and we will continue to test a wide variety of different research projects in this facility. For example, we have tested full-scale systems for roofing, like standing seam metal roofs, roof paving systems, tiles, shingles, and so on. Those can be tested essentially at full scale, and it allows us to look at the way the whole system performs under wind loading, as well as its interaction with the wind loading. So that's a very important role of this facility. We also have been developing techniques that are applicable to smaller structures, which we call partial turbulence simulation, which allows us to put relatively large-scale models in the facility, and we combine the test data with other analysis and computational methods to give us predictions that include all the big-scale turbulence that we may not be able to include at that scale in this facility. We've done testing related to the transportation industry. One example would be variable message signs. We've done a project here with a PhD student whereby we've refined the aerodynamic coefficients used in the AASHTO code and the gust factors, and we've looked at the phenomena of vortex shedding and galloping, which could cause vibrations of these structures at high wind speeds. That's another example of the application of this kind of facility.
One of the most important aspects of wind engineering research is related to codification of research findings. So here at the Wall of Wind, we test small, large, and full-scale models in order to extract those important information that we can use in order to enhance current building codes and wind standards. The codification process in this type of studies has a direct impact on people's safety and economic development of our community.
So the STEM Transformation Institute makes use of this classroom to allow students to learn about their sciences in the classroom as scientists. In this case, this is a bridge between the Wall of Wind and students learning in the classroom. So it brings the Wall of Wind straight into this classroom where students are going to learn about it through this active learning process.
Wall of Wind was used to develop and validate various innovative mitigation techniques for lessening hurricane impacts on structures. One example is the validation of Aero Edge, which are edge devices that can be put on roof to reduce the wind uplift damage on roof components. This product was developed by the industry partner of the Wall of Wind and has been patented. Wall of Wind has proved to be a multi-user research infrastructure, both for national and international researchers.
The vision of the Wall of Wind facility is to significantly advance the state-of-the-art in wind engineering research and education, and to impart resiliency and sustainability to new and existing buildings, cladding systems, and lifeline infrastructure, so as to prevent wind hazards from becoming disasters.
Example of what we've done at the Wall of Wind. You see on the left-hand side, gravel on the flat top and a heart-shaped area where there's no gravel because the wind blew it away. But on the right-hand side, we have these turbines. These turbines are conical shaped and they prevent that from happening, damage on that flat roof. But at the same time, they produce electricity. So it's a green solution, a renewable energy solution. During a hurricane, you can create your own power when the power goes away. All right, here's another really special demonstration we did for a media team. There's no audio on this, so I'm just gonna tell you about it. So we had a special media team that came and they wanted to see the Wall of Wind and they wanted to see something destroyed. That's the media, right? Well, we said, okay, we'll do that, but we want a teachable moment. We wanna teach you how to prevent damage. So we came up with this very special structure where one side was fortified and one side was not. So there it is. And we put little things in front of it like a barbecue grill and a bicycle. So here's the strong side that had shutters and roof tie downs to make it strong, okay? And then on the other side is what we call the weak side, where we did not have metal shutters on the windows and roof tie downs holding down that roof. So we hit the strong side first with the Wall of Wind, and we got up to Category 5 wind speeds with no failure for less than $250 in cost. Then we spun the structure around to the weak side with no mitigation, and watch what happens. Catastrophic failure. Watch that roof. That flew very far downwind, over 200 feet. The flying debris spreads everywhere. So you can imagine in a community of structures that are not built and mitigated and resilient to strong winds, this is what happens. But we showed them quite clearly how you can, for low cost, fortify and strengthen a building. So the media team, they got what they wanted and we got what we wanted, that teachable moment. So when it comes to roof design, I always talk to the kids, you have a flat roof, you have a hip roof, HIP, and then a gable roof. Which one's the best in a hurricane? And the answer is the hip, because the hip is more aerodynamic because it has sloping on all four sides. And engineers look at pressures, positive pressure or negative pressure, either pushing or pulling a building apart. And that's important when designing a building. So how do you hold that roof on? Well, you can see in the attic of many homes, we will have these metal straps called hurricane straps to hold that roof in place, and adds a lot of strength. For many homes in the United States have these big garage doors. That's a weak point. So you can fortify and strengthen to have a strong garage door that will not fail. Because this is what happens. This is Hurricane Maria in Puerto Rico. Flying debris is what you need to protect your home and windows from. So you can have wood shutters, plywood, or metal shutters. And I always ask the students, what's stronger? And they always say metal, which it is. You can use plywood, but it's very difficult to put up correctly. They're heavy, and they may not be secured on there tightly, and they may blow off. So a metal shutter is the best route to go when putting up a shutter. And we have to stop doing this. Tape. Tape does nothing. And what's funny, when I show this picture to the students, I don't say anything. And it never fails. The class starts laughing. The students start laughing because they get it. They go, tape? Why would you use tape? And it's funny how the kids, the students know, but adults still don't know. We used to all put up tape, but now that's old education. Now we have new education, and we know better. And one new piece of information in a home or building, close all the interior doors to the bedrooms, closets, laundry rooms, whatever the interior doors are, because that can then add strength when a hurricane is coming by in terms of pressure. And all of us can get a wind and mitigation inspection of a home with a certified contractor inspector. You can now determine and get a scorecard. How strong is your home? So an instructional activity might be, you can have your students get a bunch of balsa wood, and then I get blue painter's tape and have all the students build little houses with balsa wood and blue painter's tape and put it in front of a small fan. And just kind of watch the whole exercise of these little houses being blown apart or blown away, but some might do better than others, but get them thinking about, okay, in designing a house, there are better ways. And when it comes back to preparedness, again, back to safety, I mentioned teach safety, but teach science, but teach safety. Generators, you know, the power is going to go out. So I always ask the students, how are you going to see at night? Candles or flashlights? And I always say flashlights are better than candles because candles can cause fire. But if you get a generator, where should you operate that? Inside or outside the house? And many of the students pretty much know you operate it outside the house. But unfortunately, there are examples with hurricanes where people run the generator inside their home. And unfortunately, it leads to fatalities. So we all have to talk about plan and being prepared and having the students make sure that, are you ready for the storm? And there's many different ways, including pets. Many students have pets. What are you going to do with your pet? And get them thinking about having a plan and all the things that you need, flashlights and batteries and can openers and food. And then having a plan, we have these cones, 5 days to landfall. Well, for a plan for a home or a school or a business, you can take that 5 days and split up your to-do list. And if the storm goes away, you turn off your to-do list. But this is a way to divide up your to-do list. So another activity in the classroom possibly is you could then create a 5-day school hurricane plan and see how that turns out. And here in South Florida, we have Broward County Emergency Management, Miami-Dade. So local emergency management is a tremendous resource for all of this preparedness information. And this summer, I was part of a big project called Eye of the Storm. We created a 12-part hurricane education video series, 12 parts. So if you Google that Eye of the Storm, Museum of Discovery and Science, there is a page where all 12 videos are there for you for free to learn about all these different topics. Eye of the Storm, Museum of Discovery and Science in Fort Lauderdale. There again is my contact information, my email, and our social media addresses. I thank you so much for the opportunity. And Rebecca, at this point, we'll go ahead and answer any questions if there are some.
Great, thank you so much. Let's see here. I don't have any questions in the Q&A, but this would be a wonderful time now. We also, because we do have a little bit of time, if anybody wants to open their microphone, if you raise your hand, raise a digital hand, you can share your comments or your questions directly, or you can go ahead and type them in the chat. Go ahead and take a moment to do that. All right, we do have one. Actually, I'm sorry, I missed this one. How can we keep the control with students when storms are ready to come? Mariano, are you able to clarify that a little bit?
You might be talking a little bit about anxiety or fear or
I think so.
possibly.
Yeah. So how do you handle students' anxiety? And
well, that's a challenge, right? And as parents, there's many different things you can be fearful of. I even gave you my personal story when that lightning bolt scared me to death. And there was a fear of storms initially, but for me, you know, that grew into an interest. But when storms are coming, it is natural. So there's different ways to mitigate, right? So to bring down the fear factor, one way to do that is to bring up the information and preparedness factor, okay? So first of all, knowing and clearly communicate, you know, what is the hurricane, where is it, but look at how we're prepared, look how we're ready with batteries, and we don't have to evacuate, we're not gonna get storm surge, we're in a place that's safe. So talking about the positive things and preparation for that, and letting them know that we're all gonna be together, work together as a team. And I always thought that if the information and education meter goes up, that fear and anxiety meter goes down. So the more of that positive information you can share, I think will help. And this may never go away, the anxiety, nervous part, because the category 5 is coming your way, we're all going to be anxious. We're all going to have anxiety. So that is normal, but there are ways to mitigate to bring the level down.
Mm-hmm. Great. I have another one, which is, where do teachers, in your experience, where do they incorporate this into their, into the coursework? Where have you seen that integration happen in a really meaningful way, considering all the things that teachers also have to teach?
You know, that's a great question, and I totally, fully respect that question and understand that question, because there's so many requirements. There's so many things that the teacher has to teach, is required to teach. And unfortunately, in my opinion now, that within school curriculums, there's not enough meteorology and weather safety preparedness taught. This comes into play a few times in the elementary and middle school education, where under physical science or earth science, some weather will come up. Mm-hmm. But there should be more, there needs to be more across all countries, because these are natural hazard events, extreme weather events, and they're on the increase. We have climate change issues. But again, knowing the science, but preparedness and safety is so important. And we in Florida, we're the hurricane capital of the country. We're the lightning capital of the country. We are the rip current capital of the country. We're the thunderstorm capital of the country. And we're number 3 for tornadoes. Of all states in the United States, our teachers should be really teaching whether not just science, but safety. So it's a great question. You try and get it in when you can and how you can, if it's not part of what's required. But I think that moving forward in the future, you know, having school curriculums included more in all countries is a goal to have and achieve moving forward, hopefully.
Great, thank you. Let's see if there's anything else. We'll practice a little bit of wait time. I've also let people know they can ask questions in Spanish, because we actually have people today here from, well, places like Grenada and Jamaica. I think I saw some of the British West Indies as well, but we also have individuals from Guatemala, from Mexico, from Peru, and from all over. ¿Tiene alguien alguna pregunta?
And as I mentioned, we're helping to promote hurricanes.fiu.edu as a resource for this information in Spanish.
Excellent. Very good. Okay. Well, I'm not seeing any questions right now. We also had a crew of people on Facebook, but I don't see any questions. Just a few comments and things like that, and I'll definitely go ahead and why don't we go ahead and share that URL one more time. Do you have the English and the Spanish URL we can put in the chat real quick for folks?
So for information, okay, so we have
Huracanes.
Yeah, hurricanes.fiu.edu for the Spanish language. And obviously there's the National Hurricane Center site. That's nhc.noaa.gov.
Great. Perfect. Okay. All right. Well, if we don't have any additional questions, I think we're good to go. We'll be sure to send a follow-up email to everybody so that you can get a recording of today's presentation and reference any of the things that Erik shared with us. So do you have anything to say to close out, Erik?
Well, again, just thank you for the opportunity. It's great to be here today to share this information with all of you. Thank you, all of you who watched my presentation. Thank you for your time today to come and watch. And the questions are great. So if there's a follow-up with Rebecca on more questions or resources where I can maybe help, please share with Rebecca and we'll do what we can to help you. And again, I give just again, lots of credit to all of you, for all of you that may be educators and the role that you play in the community and with our young adults, our students, who are going to have to take these challenges of the environment. They're the next ones to then come up with solutions for the challenges when it comes to natural hazards and climate change. And so for all of you that are getting them ready to be that next generation, the work you do and how you're dedicated to doing it, I thank all of you and just wanted to make sure that you are appreciated each and every day. Thank you.
Great, thank you. It looks like a number of folks, both on Facebook and and here in Zoom are. Thank you very much for the very comprehensive information. So thank you so much, Erik. We really appreciate it. And before we close out, I do want to share my screen really quickly just to notify people about some upcoming things with I-10, because this is not the only presentation that Erik is going to be giving. As he mentioned, he is part of a community between a number of American institutions and also Jamaica. And as part of that work, they will be presenting at our I-10 annual seminar, which I will click on right here. And I want to invite all of you to participate. Basically, this seminar will be held on November 13th and 14th. It will be a very interactive space in which folks from the public, including yourselves, if you're a teacher, if you're somebody who works with teachers or works with students, specifically related to STEM, we invite you to contribute either a presentation through a poster or to be part of a roundtable discussion. And we also encourage you to come and attend a number of presentations that will be given by people from all over the Caribbean and all over Latin America, and of course, the United States as well, which doesn't quite fall into either of those categories. So I strongly encourage you to look that up. Applications to participate are available until November 6th. And if you just Google, OAS I-10, and then if you go to that main link or click on seminars right there, you can find the information. So if you have any questions or would like to participate, please do reach out. You can just respond to any of the emails that you've gotten from the automated system. So I'll leave it at that for now. And again, thank you so much, Erik, for sharing everything. We look forward to your presentation in mid-November as well with your team.
You're very welcome. Thank you.
Thank you. Have a good afternoon, everybody.
Okay, bye-bye.